That 503 is the point. The workflow works until an outside service fails, so the real problem is what happens after the request breaks too now. The mental model is simple process normally, detect failure, then recover deliberately instead of letting one system decide if automation stops. Now the same workflow succeeds and returns structured output, proving the path works before we add planned failure handling around it safely. The pattern is not specific to Groq. APIs, databases, payments, and pipelines can fail independently. So recovery must stay consistent systems. Production adds uncontrolled dependencies. An API can fail, recover, then another service can fail. So one strategy cannot fit every dependency. That is the real world gap. The happy path expects success while production exposes timeouts and rate limits that can stop automation quickly. Failure is normal because dependencies break. Architecture must detect each failure without assuming every component needs the same action on. Temporary and permanent failures need different responses. Retrying a transient timeout can help while retrying bad data simply repeats the problem. Blind retries create a bottleneck. Queued requests keep growing, while controlled retries use bounded attempts and delays to prevent backlogs. Here, the queue keeps climbing under blind retries while controlled retries stay bounded. Next, we make control explicit inside n8n for this workflow. The workflow returns to the trigger side where there is no output yet, giving us a clean starting point for controlled failure handling here. The request deliberately targets an HTTP 503 endpoint, creating a predictable failure so retry behavior can be tested instead of guessed beforehand. The request body contains a model and customer support message, so the failure test stays close to the real automation we want to protect here. We keep the request table here because changing payload and recovery logic together makes it harder to isolate exactly which part failed. Now, the configuration stays unchanged. That matters because a reliable retry test should separate request correctness from failure recovery behavior. Now the 503 request executes and the node remains active instead of immediately revealing the final failure state that we need to handle. Now, the request fails with service unavailable and 503 giving us the exact transient error condition that the recovery layer must recognize and handle. Retry on fail is enabled with 3 attempts and a 2-second wait, adding bounded recovery without creating an uncontrolled retry storm. Now, the retry settings are ready, but we also need the request to represent the real service, or we are only testing failure handling mechanics now. The endpoint switches to Groq's chat completions API and the workflow now runs against the service we actually intend to automate for real now. The API call succeeds and returns output, confirming the request path works before we inspect response that downstream logic will consume safely. The response stays highlighted while we inspect its structure because downstream nodes need stable fields and clear content reliably, safely. The output includes reasoning, timing, and usage metadata, giving us a working request with predictable fields for the next reliability decision. The output includes reasoning, timing, and usage metadata, leaving a working request and enough structure for the next reliability decision ahead.